Pavement Classification Rating. This video provides an overview on what PCR PCRs are. We will demonstrate how to use FAARFIELD to model existing pavements and calculate PCRs. Refer to Advisory Circular AC 150/5335-5, Standardized Method of Reporting Pavement Strength, PCR, for the basis of reporting pavement strength, and AC 150/5320-6, Airport Pavement Design and Evaluation, for the basis of the design and evaluation procedures implemented in FAARFIELD. This video will include overview of ACR PCR, demonstration of how to use FAARFIELD to calculate PCR, Aircraft Classification Rating ACR and Pavement Classification Rating PCR is the International Civil Aviation Organization ICAO method to report pavement strengths. These ratings allow aircraft operators to evaluate the load carrying capacity of airfield pavements and determine if individual aircraft operations can be accommodated. ACR is a number that expresses the relative effect of an aircraft at a given configuration on a pavement structure for a specified standard subgrade strength. PCR is a number that expresses the load carrying capacity of a pavement for unrestricted operations. The ACR PCR system is structured so that the pavement can support, without restrictions, aircraft that have an ACR less than or equal to the pavement's PCR. The use of PCR is only applicable to pavements at public use airports with bearing strengths of 12,500 pounds or greater. Pavements with bearing strengths less than 12,500 pounds only need to report aircraft gross weight and gear configuration. The new system is reported using the same 5-part reporting code as used with the previous system. However, there is no mathematical correlation between previous ICAO pavement strength reporting systems and the new ICAO ACR PCR system. You must do a PCR analysis to report your PCR. The ACR PCR method uses the same 4 standard levels of subgrade strength for both rigid and flexible pavements. Layer elastic analysis (LEA) methods are used to evaluate support requirements for both rigid and flexible pavements. The ACR for flexible pavement is 2 times the derived single wheel load calculated at a tire pressure of 218 psi relative to the thickness required for 36,500 passes of the aircraft. The ACR for rigid pavements is calculated at a standard stress of 399 psi. The FAA developed a software application, ICAO ACR, that calculates ACR values using the procedures and conditions specified by ICAO. This application is included within the FAA's FAARFIELD 2 software. Remember that the PCR is reported in terms of the load rating of the aircraft that the pavement can accept on an unrestricted basis. Unrestricted refers to the relationship of the aircraft ACR to the pavement PCR, and that it is permissible for an aircraft to operate without weight restrictions when the PCR is greater than the ACR. The term unlimited operations does not consider pavement life. The reported PCR indicates the pavement strength is sufficient for the current and future traffic analyzed, and should be re-evaluated if traffic changes in frequency or composition. How to calculate the PCR. AC 150/5335-5, Chapter 4, includes a 13-step process for determining a pavement's PCR. FAARFIELD automates much of this process. The user enters the pavement structure and traffic into FAARFIELD, and FAARFIELD performs steps 3 through 13 as part of the PCR analysis. PCR is reported as a 5-part code. 1. Numerical PCR is 2 times the derived single wheel load reported in hundreds of kilograms. 2. Pavement type is either R for rigid or F for flexible. 3. Subgrade strength category is divided into 4 standard strengths for calculating and reporting. 4. Allowable tire pressure consists of 4 codes representing unlimited to low PSI. 5. Method used to determine the PCR is either T for technical or U for using aircraft. Numerical PCR indicates the load carrying capacity of the pavement in terms of a standard derived single wheel load at 218 psi. For pavements with numerous sections of diverse strengths, the controlling PCR for the weakest section is generally reported. Engineering judgment may be required. For PCR pavement types, reflect how the pavement structure functions. Rigid pavements support loads through flexural action, where flexible pavements support loads through bearing at the subgrade. Engineering judgment must be used when evaluating composite pavements. For example, a pavement structure with a thin asphalt overlay of a rigid pavement is generally reported as rigid. However, a thicker asphalt overlay over a rigid pavement may be best modeled as a flexible pavement, treating the rigid pavement as a stabilized base. FAARFIELD reports the appropriate analysis based upon the pavement structure as an input into FAARFIELD. Subgrade strength is the same for rigid and flexible pavements. Subgrade strengths are classified from ultra-low to high based upon subgrade modulus. The tire pressure categories are the same for rigid and flexible pavements. Tire pressures on flexible pavements may be restricted depending on the quality of the asphalt mixture and climatic conditions. Tire pressure limits are normally not required on rigid pavement unless pavement is very thin or in poor structural condition. Typically, arrival traffic weighs less than departing traffic. Because of this, only departures are considered in the analysis. When the weight of arrivals and departures is similar, there may be a need to adjust the traffic considered in the PCR analysis. This might occur when aircraft are not refueled or at airports where there is no parallel taxiway. See AC 150/5335-5D, Appendix A, for additional discussion on traffic. When the analysis type is changed to PCR, FAARFIELD adds a field P/TC to adjust the pass to traffic cycles when airfield configuration requires adjustments to the amount of traffic used in the PCR analysis. All technical evaluations involve the same 5 steps. 1. Determine traffic, type of aircraft, and number of annual departures. 2. Determine subgrade stiffness. 3. Determine pavement characteristics of each layer above the subgrade, material type, thickness, and elastic modulus. Note: modeling existing pavement structures in FAARFIELD often requires the use of user-defined layers. 4. Determine pass to traffic cycle ratio. 5. Run the PCR evaluation. Using the technical evaluation, we will evaluate 3 pavement structures, one with a CDF approximately equal to 1, one with a CDF less than 1, and one with a CDF greater than 1. For scenario 1, where the CDF is approximately 1, let's use the following pavement structure. 4 inches P401 HMA surface, 5 inches of P304 stabilized base, 6 inches of P209 crushed aggregate, and 15 inches P154 uncrushed aggregate on a subgrade with a modulus of 12,000 psi. Use the same traffic shown in Example 1 in Appendix B1 of AC 150/5335-5. This traffic is similar to what may be seen at an airport with international traffic. Once you have entered the pavement structure and the traffic, select Run to start the PCR analysis. When the PCR analysis is complete, the status window indicates PCR calculation complete, and the PCR value is reported as PCR equals 631/F/C/X/T. Note that for flexible pavements, FAARFIELD defaults to reporting the tire pressure as X. The engineer must evaluate the pavement condition and determine what is the correct tire pressure to report. At the far right side of the traffic window, 2 additional columns have been added. One represents the ACR thickness needed to support the individual aircraft, and the other is the ACR value for that vehicle. In reviewing the PCR report, the analysis type is New Flexible, the subgrade is Category C, and the CDF is 0.76. Table 1 is a summary of the input traffic used in the analysis. Table 2 includes the PCR value for the pavement structure. Table 3 includes the ACR for individual vehicles. In this example, all of the ACRs are less than the PCR. The PCR graph presents this data. Save the report as PDF to enable inclusion in the engineer's or pavement management report. In the next example, consider a rigid pavement structure similar to the rigid pavement example 1 in AC 150/5335-5D, Appendix B, Paragraph B 8.1. The pavement structure consists of 16 inches of concrete surface with a flexural strength of 650 psi, 8 inches of asphalt stabilized base, and 6 inches of crushed aggregate base. From tests on the runway, the subgrade modulus is estimated at 7,800 psi. The airport has a parallel taxiway and fuel is obtained at the airport. Therefore, the pass-to-traffic cycle ratio is 1. After entering the data, with analysis type set to PCR, click Run. When the calculation is complete, the computed PCR value is 917/R/D/W/T. FAARFIELD automatically identifies the correct subgrade category D, as well as the correct tire pressure category of W. Looking at the traffic table, we see that the total CDF is 4.85, indicating that this pavement structure has insufficient structural capacity for the composition and frequency of traffic. Looking at the ACR values of the aircraft and the traffic, the computed ACR for the Boeing 777 is greater than the calculated PCR. Alternatives include A. Restricting the operating weight of the 777, B. Overlaying the pavement to increase structural capacity, or C. Until the overlay can be completed, allowing the overload operations of the 777 inspecting the pavement. Operations of the 777 are about 7% of the total operations, and the ACR of the 777 exceeds the PCR by more than 13%. Refer to AC 150/5335-5D, Appendix C, for more guidance on evaluating overloads. The actual strength of the PCC is important in a rigid PCR analysis. For example, if tests or construction records support a flexural strength of 720 psi, the PCR is 1089, versus the ACR of the 777-200 at 1040. In our third example, we will evaluate flexible pavement in an area subject to seasonal frost. To satisfy the requirements for frost protection, the frost-susceptible material was excavated and replaced with P154. The as-built pavement consists of 4 inches P401 asphalt, 5 inches P401 stabilized base, 8 inches P209 crushed aggregate base, and 60 inches P154 aggregate subbase on a subgrade with the CBR4. The traffic is the same as used in example 1. After running the PCR analysis, reviewing the PCR report reveals a PCR of 1,581/F/D/X/T with CDF 0. Since there is no upper limit to PCR, it would be acceptable to publish a PCR of 1,580. Since none of the aircraft in the traffic mix have an ACR anywhere in that range, a more conservative approach is to publish a value greater than the largest ACR in the current traffic. In this example, the Boeing 777 has the largest ACR of 882. A reasonable PCR might be 900/F/D/X/T. This would ensure that all traffic currently using the airport can operate without restrictions. In summary, we have covered what PCRs are and how they are calculated. We also looked at the calculation and evaluation of the PCRs using FAARFIELD. See AC 150/5335-5 for detailed information regarding standardized method of reporting airport pavement strength, and AC 150/5320-6 for additional information regarding FAA standards for pavement design and evaluation. Please visit www.faa.gov/airports to find these documents, this tool, and other related design tools. For additional information, contact the FAA's Office of Airports. The FAA appreciates your interest. Safe landing.